All right. Whoa, loud. Hello, everyone. Sorry, I'm glad I got your attention. Anyway, I guess I'll get started because it's 4:20. It's about high time I got started. Anyway, sorry. My name is David Khourshid. I live here in Orlando. I'm very excited to be talking at a shopping mall. It's my dream. And I'm going to be talking to you about mind reading with intelligent and adaptive UIs, also known as AUIs. So, just a little bit about me. I work at Microsoft, as you could tell by my computer, and that's pretty much all you need to know about me. You could talk to me afterwards and we could get to know each other. So, the most important concept here is realizing the fact that all of your users are different. We all have different needs. Every user uses your app in a different way. And so because of that, I say that A/B tests are essentially ineffective because we're only testing like 2 personas where our users could span infinitely many personas, right? And also, user flows are not always linear. So there's no step A, step B, step C, but often it branches out and users could do different things depending on what goals and what tasks they have to accomplish. And so this is an important realization, and this is why I also think like those funnel charts that you see in Segment.io, those aren't always effective either. So Google has released a few tools such as guest.js, which really help adapt to individual users. And so if you haven't heard of guest.js, it's basically a way of prefetching pages based on where the user has gone before. So it uses Google Analytics, and it is able to predict on an application that uses Webpack which page the user is going to visit next, prefetch that data so that it loads quickly for them. Now, Google at the latest Chrome Dev Summit also released React Adaptive Hooks, which is really, really interesting because it provides you a lot of hooks for measuring like device memory usage, device power, device internet speed, whether you're using 2G, 4G, whether the user has requested limited data, so that you could provide adaptive user experiences for them. And so you're going to be seeing a lot more of this coming in the future, this idea of adaptive user interfaces. So what do I mean by adaptive user interfaces? So when we think of responsive user interfaces, we think of user interfaces that respond according to the device dimensions, right? Adaptive user interfaces are different. They respond to the user. So depending on what your behavior is, the user interface might behave a little bit different. So one of the earliest examples is Clippy. So as you remember, when you're using Microsoft Word or Microsoft Excel, Clippy would pop up and contextually tell you, hey, I think you're working on this. Would you like some help with this? And so this is an example of an adaptive user interface. So consider that you're making like some sort of inbox application, right? There's many different paths that you could take. We could view the latest emails, or we could compose a new email. You know, we could save that email as draft when we compose it, or we could send it right away. Now, users might do different behaviors, in this inbox app. And so it's important to measure what users are actually doing in real time, because we could adapt the user interface to say, you probably want to view the latest emails instead of composing a new one, so that's the view we should probably show you first. And also, if you're creating a new email, you might want to send it all the time instead of saving it as draft. And so that's why measuring these data points is important. And also, adaptive user interfaces can really help limit the number of steps your users need to take to accomplish a certain task. For example, if you have a simple delete user flow where you ask, are you sure, yes or no, I'm sure a lot of us have implemented this, then we might notice that the user always clicks yes. So in that case, what we want to show instead is just a simple deleted with the option to undo. And you see this in Gmail as well, where you have send, and then it says, yeah, you sent your message, but you have I think a 10-15 grace period, 10-15 second grace period to undo that. And so one of the more recent advancements in adaptive user interfaces that I use all the time is this, I don't know what you call it, like swipe to autocomplete your email messages. And I use this so often, so whenever you get an email from me, it's probably Google talking to you because, I can't craft good emails. So use that all the time. Also, adaptive user interfaces are really good for power users who know what they want to do and they don't need all these options or extra help, and they could have a streamlined workflow, whereas other users might need adaptive user interfaces to change and actually assist them. So developing these adaptive user interfaces is challenging for many reasons. I mean, we want to see which parts do we want to adapt. Do we want to adapt the overall application or just specific components? Do we want to give users the ability to adjust their preferences and manually adapt the user interfaces themselves? But besides all of this, the key is creating a model-driven development workflow with your company, with your projects. And what this means is that instead of just, just developing and writing code, moving fast and breaking things, we're actually creating a model. And so we're not doing anything except planning out how we're going to program all of our features at the very beginning. And so creating a model looks a lot like creating these user flows, these user diagrams that you might have seen, where we say, this is going to be one state of our application, and the user could do this, which takes them to this state, or they could do something else, which takes them to another state. But this is all based on a mathematical principle called finite state machines, which, if you know me, I talk about this a lot. So I'm going to give you a quick review on what these are. A finite state machine has one initial state. That's a start state where everyone starts. And then there's a finite number of states which you could go to, like the off state of the projector. Did it go to sleep? Yeah, it's like that. Yeah, final state, right? Well, that's fun.
Killed the projector.
I know. Oh, I see my computer doing something, which means something must be working. So, 3, 2, 1. Did it just overheat?
I think so.
Is that one of the Black Friday projectors? That's okay, I will make gestures while this is working. So, finite state machine, you have one initial state, right? That's where every user, when they go into your application, that's a starting state. Then you have a finite number of states, and these are the different possible states that your users could go to. And then, I'm clicking, you're not going to see this, but you have a finite number of events that can happen. Now, these events can be initiated by the user doing something like clicking a button, or they could be events such as a request resolving, or some failure happening, or some internal event, right? Are we back? We're back. Awesome. Thank you. Any questions? Sorry. You also have a mapping of state transitions triggered by these events and a finite number of final states as well. So you could essentially just look at this as states, events. When an event happens, just follow the arrow. It doesn't get simpler than that. So it's just like, you could think of it as a flow chart, user flow, diagram, and it also prevents impossible states such as this. So, I mean, we don't want to see this in our application, and state machines ensure that you're only in one state at any given time, and that when an event happens, it's always going to go to its designated next state. So you can make finite state machines with switch case statements because this is such a core concept in computer science and programming languages that you're basically matching on what the state is, such as searching, what the event that just occurred was, such as a resolve event, and then you would return what the next state as a result is. But what I like to do is use object mapping, and in this case we would have in a key of an object, which is the state, and then another nested object where we map events to the next state. So when we're on the searching state and the resolve event happens, now we're in the success state. So I created XState in order to handle this and many more complex parts of state machines and state charts such as hierarchical states, parallel states, managing declarative effects, delays, interpretation, and a lot more. So I encourage you to go to xstate.js.org in order to to find out more about this. And so XState also encompasses principles from hierarchical state machines, also known as state charts. This is not a new idea. This was created by a computer scientist by the name of David Harrell in 1987. So that's more than 30 years ago, and these ideas are still used widely today in many other programming languages. Also, XState can be used in Vue, Angular, Svelte, React, anywhere where you could basically subscribe to an object and send data to that object as well. It's a very, very simple paradigm. So let's take this in an example. Let's say that we have a feedback form, right? We say, how was your experience? The user could click good or bad, and if the user clicks bad, we take them to a screen that asks them to tell them why you had a bad experience, and then regardless of if you click good or you submit the form, it'll say thank you for your feedback, and then you could close the form. So this is how it looks like. We have a good or bad, you click good, and then if you click bad, you could just write feedback there. And so you can see we could describe this as a simple state machine. But I want to make it adaptive, right? So let's come up with a game plan for how we can make this adaptive. The first step is to create an abstract model, and that's the state machine that I'm talking about. And then we want to have analytics on those transitions and measure how often users are going from one state to another and when they're doing so. Then we identify the adaptive paths, which are the paths where we could say, you know what, if a user prefers this more, let's take them there instead. And then we could use the analysis from step 2 in that automatic adaptation in real time. So there's a few concepts we need to learn in order to do this. First is weighted graphs. So a graph is just a collection of vertices and edges, or nodes and edges. And so you could think of each node as one of these states, like signing in, success, or error, and one of the edges as these arrows. But here's the thing, these edges can be weighted, which means that one can be traversed more often, or however else you want to measure the weights, like time it takes to get from one to the other. And so we could have what's called a weighted graph in which one edge has more weights than the other edge. And so this is an important realization in designing your UIs, because you might think of your UIs now as a collection of states and transitions. However, the reality is when your users use it, it looks a lot different. So it looks like there are paths that are traversed more by your users than other paths. So I used this technique when I was working with the VS LiveShare team, and I used state machines in how many of you have used LiveShare before, actually? Awesome, this is half of the room. I don't know what's wrong with this half. LiveShare is a way for you to collaboratively code between 2 or more people from anywhere in the world in VS Code. So it's a really, really cool tool that you should check out. Anyway, we had a lot of complex UI states, and I wanted to first simplify all the code that prevented impossible states from happening, and make sure that we had a very succinct and clear way of representing what each state in the UI, which is VS Code, would show. But I realized too that I could add analytics, or I could add telemetry to this. And so as a result, this is a Power BI representation taken from the data that I collected from those automatically from those state transitions, and we saw that we created this weighted graph and saw whether people were signing in externally more, or were they signing in directly, whether more people were sharing or joining sessions, and we could just analyze the data as is. So let's create our adaptive user interface now that we know about weighted graphs. So I want to have this bad button be an adaptive path, where when we click bad, it either shows them the form, or it takes them to this thank you for your feedback, where they could optionally give feedback. And so the reason that we would want to do this is, I'll show you, let's exit here, is that, oh wow, I can't zoom in. Anyway, it's because let's say that as a user, I click bad, and then I see this form, and I'm like, you know what, I really don't feel like filling this out, so I'll just exit out of it. Now when I reload the page, what I'm doing right now is I'm measuring these transitions. So right now they're very, very simple measurements. And so let's say that I just keep clicking bad, I keep exiting out, like I'm having a real bad experience over here. The idea is that by automatically collecting these transition metrics, what we could do is we could adapt the user interface in real time so that when it shows again, it will actually take us to this new screen. And then this one will optionally give us the option to provide feedback manually. And so that's an example of a very simple example of an adaptive UI. So we could analyze these transitions based on how frequently they're taken. And let's say that we're making an Instagram application, for instance. We could say that when we first log in, that the user wants to go to the camera more. So we could measure just the weights of the different paths and say, you know what, open the camera and provide a direct path to show the camera instead of the gallery or the profile. We could also use decision trees in order to help us too. And so these decision trees measure different data points and allow us to make more granular decisions based on these different data points. And this is a technique used in machine learning and reinforcement learning a lot. So this is something that I do encourage you to look up. I'm not going to spend too much time because I have like 3 minutes left or something. Anyway, these analytics, one of the best things about using state machines and state charts in your application is that managing state only falls into one single place, your transition function. And what that means is that we could track our analytics in one single place. How many of you have had to add analytics just like telemetry throughout your entire app, just copying and pasting? I mean, that's a really, really annoying process. So having it in one place makes things a lot simpler, where you would track what state that you're going to, what state you came from, the events where you would also sanitize that for preventing user information from spreading, and also have a timestamp just to see when that event occurred. And that's all the information you need. And so from that, you could have very detailed data on how your users are using your application. So I thought about future ideas for analysis too, and I looked up higher order Markov models, which are definitely interesting because when researching this, I realized a Markov model is basically it's a linked chain, right? Between states. And so let's say that a user, or users in general, would go from state A to state B more often than going to C. So while this may be true, another important consideration is which state they came from before. So let's say that coming from state D rather than state E, they were more likely to go to C. So then, in order to prevent faulty predictions, we should use these extended Markov models to predict based on 2 or more states. Also, I experimented with using deep reinforcement learning, taking those analytics and actually having some sort of agent predict what the next state is going to be. And so reinforcement learning, just a quick 5-second intro, it's basically you have an agent, and an agent takes a potentially random action, and based on whether we think that that action was a good or bad action, we reward or we punish that agent, and eventually the agent, after many times, learns what the correct thing to do is, and it would do the behavior that we expect. And so you could feed this agent within the environment, which is your model, and make it predict what the user will do next, even for paths and different states that have never been taken before. And so you might be thinking, wait, seriously? I don't have time to really show you a demo, so instead I'm going to show you this video of a very simple tic-tac-toe game. Now, this tic-tac-toe I made using React and XState, and because of that, I was able to analyze all of the movements that users made, and I played this a few hundred times, so we could see that there's a frequency graph on each of the squares that shows what the next ones were played most often. Now, instead of playing them manually, I actually fed it to a reinforcement learning agent right in the browser, and it was able to play like a human, even for, so you could see, it just plays based on frequency. But when it encounters something that's never been played before, it will still play like a human. And in this case, I made a stupid move, so it won. And so that was just using reinforcement learning in the browser to predict that user behavior. So, in long story short, if we have an application, we can model that application using this abstract model, create an executable model out of it. In this case, the model is a state machine. Use metrics tracking like we've showed, and collect that within, say Google Analytics, or Kissmetrics, Mixpanel, Segment.io, and feed that back into the model to have adaptive transitions. And in results, we have this adaptive UI that responds to user behavior in real time. And so this idea of using abstract models really, really benefits the user, because for the developer, we have this determinism, we have the ability to visualize our models and communicate between designers and other stakeholders. But with users, we have this analytics in order to improve the user experience for them in real time without having to have long dev cycles or these specialized UIs for different groups of users. And so XState, I now have this XState analytics package, which I still have to write documentation for that allows you to capture those metrics directly. And also I'm coming out with the next version soon, but you could try it out at XState at Next if you are using XState. And there is also a really cool visualizer which you could copy paste your machine definitions into and play around with them. And so, yeah, long story short, lots of resources for you. And the goal of all of this is to make your code do more. So thank you, DevFest Florida. I don't see the other speaker, so any questions?
All right, my name is Hugo. I'm a UX designer. My question is, what's an alternative to A/B testing that can allow designers and developers to make their platforms more adaptive?
So the alternative to A/B testing is, I said like A/B testing is sort of like you're pigeonholing like two different like possible views. So instead of that, just realize, all right, let's create a possible way for users to use this user interface or like a separate variation of that user interface. And so that's the tricky thing about adaptive UIs. It's like picking those designs and just choosing the right ones for your application. So with adaptive user interfaces, you really want to see how your users are using the app. Are they running into errors? Do you see them making the same actions over and over again? Those are points where you could observe and you could say, you know what? That could use an adaptive transition. As in, for these types of users, they could go here. For other types of users, they could go here. For others, they could go here. But this isn't based randomly. A/B testing is random. It's like 50% goes here, 50% goes here. Adaptive transitions are more, these users who are more prone to do this go here, or here, or here. So it's more like an A to Z rather than A/B testing. But based on analytics, not based on random, chance. All right, well, that's it. Thank you very much.